continue. I want to talk about a bit more formally about test reviews and things to look for. So what we've done so far is we've looked at tests and randomly I said things, but there is a system to the whole idea. There is a list of things that I look for. So first we're going to talk about test reviews and then the three pillars of what, to me, make good tests. The first thing to understand is that test reviews are one of the most effective ways that you will have to spread knowledge in your organization and to help unit testing actually be adopted in your organization. So if you want to have any hope whatsoever of having unit testing adopted, you're going to have to learn and actually do test reviews in your organization. And the reason is that there is nothing better than simple face-to-face human communication, sitting down in front of the same code and finding interesting things and how to make them even better. Test reviews, but there's also a benefit to doing test reviews versus just regular code reviews. If you start code reviews from the tests, the main benefit you're going to get is that your reviews will usually be shorter, sometimes up to 10 times. The main reason is that when you have tests, then the test itself reveals the intent of what the developer was trying to do. When you look at code, you don't see intent. You have to read a bunch of lines of code to understand the intent. So in real code, sometimes you're going to have to read 20, 30, 50 lines just to understand that they're doing the wrong thing, that they got the requirement wrong. Sometimes when you look at it, so you might say, you go to the end of the method and then you say, oh, so you delete the object from the database only when this is true, but it takes time to understand this. When you sometimes, by just looking at the name of the test, you realize that something, that there was a misunderstanding, even before looking at a single line of code. So test reviews are a good way to understand the intent of developers, and they're a good way to drill down into code when you want to review how things actually got done. So you see what the developer tried to do, then you can drill down from the method, which is a test, to see how it actually got implemented. The three main pillars of good tests are readability, maintainability, and trustworthiness. If you even lose one of them, then then the rest will break. Why do we need readability? What's the point of readability? What do we get? Nothing?
A quicker overview of what's happening.
It allows us to do review quicker. It allows us to understand why a test is failing, when it's failing, so it will allow us to find the bugs faster. What about maintainability? What's a maintainability in a test? What does it mean? Yeah.
Yeah. Well, if we change the structure of the code, that's easy to maintain the test as well. So we don't have so it's not a complicated structure that we have to mess around a lot with. So it's easy to change.
So if we change the structure of the code becomes easier to change. The tests are actually easier to change than if we weren't keeping them maintainable. In fact, this is one of the biggest problems with tests, is that they add extra maintainability cost to our code. So the maintainability aspect is one of the things we have to worry about a lot in terms of tests, even more so than regular code. Because in regular code, we might have one thing, but in tests, you might have multiple tests for that one thing. So there's actually, you actually have a shotgun effect, that when you change that one thing, you actually get to maintain 5 or more different other tests. Trustworthiness is the one thing that it's always the hardest to explain. But the way I think about trustworthiness is, what happens when you see the test result of a passing test? Do you still feel the need to debug the test? If you do, then you don't really trust the result, and it's not really saving you any time. Also, trust is when tests can lie to you and they say that they fail for the wrong reason, so that you stop believing the tests because the result that you get is not the result that should have been. You know the test should pass and it fails, and you know that it's a configuration issue. And this is a problem because when we stop believing our tests, then again, we're not really saving any time by listening to them. So we don't really know that things are broken or not. We have to go and find out for ourselves. Now, if we lose trust, then we won't care about the readability or maintainability of the test. We just won't run them or we won't change them when they start failing. If we lose readability, we won't be able to maintain the tests. And then eventually we won't trust them. If we can't maintain the tests, it's just a matter of time until we stop using them altogether. One of my first projects ever was a project where about 6 months into the project, or 8 months, I don't remember exactly, we had to stop working on the test. We had to actually delete some of them, a lot of them, about half, because they kept failing and we didn't have time to keep fixing them. And that's where the maintainability really came in. And so all that time we spent writing them and learning how to write them, etc., we actually threw it in the garbage. So we don't want to go through that again. So one of the things that I already said is that in terms of readability and trust, we want to make the tests easy to run, and we want to separate the unit tests from integration tests. Now here in this structure, this is the nerd dinner test, and there's only one project that contains tests, so there's no separation between unit and integration. And that's one of the easiest things to fix. But also when I look at tests, I look at the structure and I look at the fact that we have fakes and models and controllers. And what I'm looking for is, if I look at this piece of code, of production code, is it easy for me to find the test for that production code? That's my test for readability. Is the structure readable? Is it easy to find one thing from another? And it should be. So usually we would have a project of tests or unit tests per project of production code. We would have at the very beginning a test class per production class. If we wanted to, we could have different matchings, but this is the easiest way to find things that match each other. And if we had a problem with how it's organized later, we can reorganize. But at the beginning, this really helps. To trust your tests and to get better understanding of how it works, code coverage is actually important, but it's only important in specific levels. So my question is, if you have 99 or 100% code coverage, what does that mean? Does it mean anything?
Well, you at least have a test that in some condition passed that code line.
Sorry?
You have enough tests to pass that code line in one condition.
You have enough tests that run, that don't break. That's all it means. It doesn't mean that anything works. It just means that nothing is throwing exceptions. If we have a 100% test coverage, it doesn't mean anything unless we review the tests and we know that they're good. For example, we can have all the tests without asserts in them, but we can still have 100% code coverage. So code coverage, which is high, doesn't mean anything without a review. What about 12% code coverage? Does that mean anything? If I have 12% code coverage, what does that mean?
So the classes are not tested?
It means that I'm missing tests. It definitely means something. If it's high, it doesn't mean anything unless I review the code and the tests. If it's low, it definitely means something, that I'm missing tests. That's what test coverage helps. But I use code coverage or test coverage also for a couple of other reasons. When I review other people's tests and code, I like to sometimes change things manually. I look at a specific test and I'm not sure whether I trust it or not. So I go to the code that's kind of under the test, and I physically change something in the code. I'll take a true and turn it into a false. I'll take an if and I'll make it always true, or something like that. Now, if I do that, which is an obvious bug in the system, what should happen?
One test should break somewhere.
At least one test somewhere has to break. But if nothing breaks, what does that mean?
That is not tested.
It means it's not really being tested, or the test that we think is okay is not really okay. Now, the reason I do this manually is about communication. I sit down with a person, they can see my face, they can see me talking and thinking out loud, and then trying this. And also, when I do this, I ask them, "What do you think? Is anything going to break?" And just by looking at their face before they answer, I can tell if they wrote it in a test-driven way or not. Because if you wrote it in a test-driven way, you're absolutely going to be sure that there's something is going to break. Yeah, totally going to break. Yeah, I know it. Because they know that that code had a reason to live. Because they wrote it only after something broke. If they didn't, they're going to have a lot of question marks on their faces. Maybe, I'm not sure, I think so. And so it's a good way to tell what is the culture. How sure are people about their code and their tests? It's not about punishment, it's about communication. It's about seeing how people react to that situation. Another thing that we want in our tests is to prevent logic. Logic is also a trust issue. The reason is that logic can lead to bugs in our tests. So we want our tests to have as little logic as possible. Where's the logic in this test? Is there logic here? There is. Logic is anything that's an if, or a switch, or a loop, anything that can change the course of work. So here's the logic right here. And what's interesting is that there are many other things wrong with this test. But for now, what jumps out to me is the fact that there is a loop right there at the bottom. So let's try and understand this test a little better. Let's look at the name. Select constructor with two parameters. Okay, is this a good name or not?
Not.
Not a good name. Why? What's missing?
The unit of the work.
The unit of work is missing? Well, the unit of work in this case is actually select constructor. So it's not missing. Okay, what's in there? Select constructor.
Behavior.
The expected behavior is missing. But we do have the scenario with two parameters. So you're the reader of the test. You say, okay, select constructor with two parameters. That's good. What's supposed to happen? And now the problem is that we have multiple things being tested as the thing that's supposed to happen. So which one of them is the important one? Because if we look at the bottom, we have asserts here in the middle. Assert are equal for the constructor, and assert that we get two parameter keys. Which one of them is the important one? Are they both the important one? What about this? Then we have a loop. For each key in keys, assert that the policy is correct for the key, whatever that means. So is the bottom loop the important one, or the first assert the important one? Because if they're both important, then they should be separated into two different tests. And the big reason is that if the asserts at the top break, then the asserts at the bottom will never get executed. However, if all of these are just asserts on the same thing, then we don't care about the asserts at the bottom if the first ones break. And for that, we would have to know the domain. We need to know in the domain what's important and what's not important. But the fact that there are multiple asserts that can break each other, that can break and then we won't know what's going on at the bottom, actually tells me that I think that that this should be separated into two different tests. If the test name had told me what's the expected one, then I would know. But one of the reasons the test doesn't tell me, I could guess, is because the test is testing more than a single thing. And so the name has to be more generic. Okay? If all these things have to be true, then they should be separated. But there are also some things that repeat themselves. We're asserting if we get back 2 here, and then we're asserting if we get back 2 here. It's the same thing. This is selected CTOR, this is selected CTOR. How could this be that the same assert is repeated twice in the same test? Any ideas? Yeah?
They copied in there, they merged 2 tests to 1 or something.
They merged 2 tests into 1 test. Interesting, that's possible. So 2 different people? And again, this is something that a test reviewer would catch immediately. So many questions just reading the test. A test should not leave you with questions, it should leave you with answers. And if you leave the test asking more questions about what the hell is going on here, maybe that's a good thing because you need to learn things. But if no test gives you good answers, then you're stuck. Okay? So how do I get rid of the loop? Well, first of all, if I know I have 2 keys, I don't need to loop. I can just have 2 statements that check each one of these. Second of all, maybe I don't need to loop to check assert on both of them. Maybe checking just on the first one is good enough. If checking on the second one is a separate concern, then maybe I should have a separate test that proves that if I have multiple, then the last one also it gets a good assert policy. Because if a single key proves my point, I don't need to use 2 keys. And that's another important thing about unit tests. If you can simplify them and use less things in the test, then do that. If you can prove this test with just a single parameter instead of 2, and it proves the same thing, then do that. A lot of times people complicate the test just to get a sense of more confidence. That's not a bad thing. But then I would put all these tests in a special class called confidence boosting tests or something like that, or experiments. And the reason is that if I look at the class, I then know that these tests don't really have the same rules as the other tests. The whole point of these other tests is to just feel more confident. Like, what happens if I now have 17 parameters and 3 different flags and all that stuff? And the point of those tests is to boost confidence. There's nothing wrong with that, as long as you make your intent clear. What about other things in this test? Are you happy with this test otherwise? Is it okay? Yeah.
The one thing is the act is just a select constructor line, and it's not separated from it. So so we have the assert, as far as I see, it would be the first 3 statements, and then we have the act, and it's not separated. It actually looks like it belongs to the other block. It was a bit confusing.
So I didn't understand. You're saying that the act, assert, or arrange is just broken here?
Yes, visually.
Yeah, visually we have assert and then another act and then another assert. Are you sure?
No. We have, if I understand correctly, the first 3 lines, constructor info specified, builder context are arranged. The next is the act, and that is not visually clear.
So the first 2 parts, you're not sure what's the act and what's the arrange. Yeah, it's usually the last line before the first assert. That's the act part. Yeah. Usually. Yeah, but I wish I had that problem. Only that problem in the test. What else?
It's a magic number.
Magic number, 37. Yeah, 37 is definitely a magic number. How do I find out what it means? I now have to look, like find in files throughout the solution. Where does 37 come from? And maybe I'll never find it. Maybe 37 is the number of methods in a specific class. Maybe it's the number of files in a specific folder. Maybe it's the number of seconds that have to go before a specific thread somewhere actually gets released. We might never find out. And that's a horrible, horrible problem. So no magic numbers. If 37 doesn't matter, just put it in a const and be done with it. ABC is kind of okay, because ABC looks like nothing. Okay. Here's another example of logic. In our tests, a lot of times we would have fake classes that implement various parameters, right? So if we have fake classes that implement various interfaces, etc., we don't want to have logic in them as well. But here is an example of one of them that has logic. You see the if right here below. So sometimes the object will behave in a specific way, and sometimes it will behave differently. Now, our test might be using this. And since this is not part of the test, it's located somewhere else, what's going to happen is that our test is going to behave in a specific way, and we won't know why. We're going to have to drill down and understand why and start debugging instead of reading how it's supposed to behave. So to avoid this, I would tell from the test how everything will behave. Just like in previous lessons, we've learned that when you have a behavior like throwing an exception, your test should be specific about telling you that the exception will be thrown from a specific fake object. It's not supposed to be magical. Also, configuration interface is assignable from is a reflection method that is very, very confusing. If you've ever used this method in reflection in .NET before, I can tell you that you always use it the opposite of how it's supposed to be used. You always think that you're supposed to send in a specific type, and it's the opposite of the type that you're trying to get. Because I tried to use it. So you can actually have a bug in this piece of logic, which is part of the tests, and so your test will behave in an interesting way, and you won't understand that you even have a bug, because you don't have tests for this code. And that's one of the reasons you want to avoid logic. Even if you think you're okay, you can have a serious bug here where you return false instead of null or whatever. Here's another example of things that could be related to logic. This is another helper method in tests from ASP.NET MVC. And this is a method that creates a fake HTTP context. So we can see that it has the app path and various other parameters. And then it has a check. If we have an app path, then create a fake application path. If we have a request path, then check and replace the app relative current, blah, 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 blah. If we have a port, then create the URI this way, otherwise create the URI that way. And then set the URI to whatever. And then the HTTP context will behave in a fake way. But the problem again is that not only is this almost unreadable, it's also prone to errors. So we want to avoid errors. Over time, this is prone to a lot of errors. Even though the ifs look simple, even simple stuff we can have bugs in. So now we might have tests that created HTTP context, and the HTTP context might behave badly. And you don't look at the helper methods to understand why bugs happen, because that's usually the last place you look at. How can we avoid all these ifs? Any ideas?
Simple test.
So, well, this is not a test.
That's not a test.
No, this is just a utility method in the tests. How can we avoid multiple ifs? You were on the right track, though. Yeah.
You just set up directly in the tests and not reuse it in this helper method.
Well, you can set it up directly in the test, but a utility method does make sense because you're going to repeat the 5 lines of code every time. But instead of having all these ifs, we can have various versions of the same utility method. So we can have multiple utility method that says, for example, get HTTP context with app path, get HTTP context with request, get HTTP context with port. And if it didn't have a port, then they wouldn't have an if, because by the fact that they're named in a specific way, they will always expect to have an app path, or they will actually break. Now, I looked, and the amount of tests that use this are exactly 2, by the way. So it's also a symbol of over-engineering. Here's an example of trust where you connect, we actually have logic that you assert against. So here, the assert at the bottom is asserting that a specific string, the expected string is built dynamically. That means that we can actually have a bug with the plus there. Now, usually what happens is that when you build the expected value dynamically, you are more likely to be repeating production code. It's very likely the production code has kind of the same code in there. So if the production code has a bug and you're repeating the same production code, you have a bug in the test as well. And so you expect the bad result in the test. The test will actually pass when it should have failed. So it's much better to use hard-coded values and strings in the test than to generate them dynamically. You're less likely to have bugs, and it's also much more readable. Questions so far? Okay, so this is a previous example of the nerd dinner test. This is an example where we had many more magic stuff, like the event date was date time now, Scott Goo was hosted by instead of some user, etc. But there are other things wrong with this test. Let's look at the name. Dinner should be valid when all properties are correct. And then we have, in the act, we have dinner is valid, and then we assert that it's true. So what's wrong with that? It's great. It's amazing. Well, what's wrong is that the test is when all properties are correct. Are these all the properties? What does correct mean for each one of them? Is the correct title mean that it has to have a space inside it? Is it the minimum number of characters? What is the correct event date? What's the minimum event date? Hosted by, does it have to start with Scott? Country has to be USA? Contact phone has to have 2 dashes inside it? We don't know. What does it mean to be valid? And also, this test, because it's checking so many things, the name is very, very generic. And every time we add a new property, we're going to have to add it to here. And we're going to forget to do that, of course. So it's much better to have separate tests for each of the properties in terms of validity. Yes?
So that would mean that, in your opinion, we should repeat every single validation logic line in a separate test.
You should repeat every logic line in a separate test.
Validation logic.
You should have a good name that explains what it is that you're testing for each piece of validation logic. If you don't have a good name that explains why it fails, how do you know how to fix it? That's my problem. My problem is that I don't know what's valid and what's not. So I need to find a way to do that. And also, there are more things here. If this test failed, how do I know which one of them was the invalid one?
I just try to think of reality and not about this seminar here.
Yeah.
And I don't know projects that you have done. So say you have 5,000, 6,000 validation rules. After a while, if you have hundreds of objects or whatever, and so you would rather make one test per validation rule. So say we have, I just fixed a couple of validation rules before we started today, and that would mean, so for every single validation rule, we get an individual test.
Hopefully more than one, because validation rules will have a true and a false result. Usually more than a single false result, more than a single true result. So if you really want it to work, you're probably going to have to test it multiple ways for each validation rule. Otherwise, it's not that important to you, right? The whole point of a validation rule is that it validates something. Well, how do you know? And validation by nature is a piece of logic. You're going to have to test it multiple ways from Sunday, basically. So yeah, it should have a separate test, at least one. Right, how do I know it's never, that it always returns valid, maybe? How do I know that? It has to return non-valid at some point, right?
Yeah. So I do know that this question will be raised, and so I don't have an answer for that now.
What do you mean you don't have an answer?
Yeah, how to make this in any fashion, in any productive fashion. But that is one of the main criticisms. If I start having, so I have say one piece of validation logic for one entity.
Mhm.
Say it's about 35 lines of code. We are talking about, well, at least 10 times the amount of tests for that. For stuff that is built in the framework, the validation itself is just using stuff that is built, it's using attributes. So I'm checking all this stuff again. And
I'm not talking about attributes here. I'm talking about pieces of logic that you want to test.
yeah, good.
Okay? So if you wrote custom code with logic for it, you have to test it. You're not supposed to test the framework. But for validation, you at least want to prove that no one deleted the attribute, right? You want to make sure?
Yeah, I get your point. It's
Now, a lot of times what you're going to get is one big validation method that checks 70 different things. And so in your test, what you're going to have to do is for each one of the validations, you're going to have to simulate that all the other validations are actually okay, right? And then only the code that validates a specific rule that you want to test that. And one of the ways to do that is with extract and override, the way we talked about before, is that each one of the validations is actually its own virtual method, and we have an override for them, and then we can just set flags to return true, false, whatever we want, except the method that's under test. And that way, we can check a specific piece of validation logic, even if it's hidden and buried inside one big method. But it's much better to have separate classes for each validation rule, because then you can test them separately. Okay? But in terms of legacy code, extract and override is great for that kind of stuff. If you're writing new code, write a separate class or a separate method that doesn't depend on anything, and test that directly with as a validation rule. Okay? It doesn't look like you got your answer, actually.
no, I got my answer, just the same answer I had before I came here, and that's so. Yeah, my opinion hasn't changed. But okay.
So
that's
what's
what
your
it-
opinion? I don't understand. Your opinion is that there's a problem somewhere?
There are definitely a couple of problems in terms of the ratio between effort and what I get for it. Whatever, I don't have to repeat your opinion. I know this already. So the problem is still I have to sell this to people, and I still have my
So
problems.
your problem is selling this to people. Do you believe that it's a good idea, though?
Not yet.
Not yet, okay. So you're going to have to try it and see. Because usually what you do, it takes about 5 or 10 seconds to create a test for that kind of stuff. So the cost is actually not that big. And the only way to test it without an integration test is to test it separately. And if you're going to use an integration test, it's kind of going to look like this, where you don't know what's supposed to be wrong. And if one of them fails, then maybe you won't know about the others that failed. Maybe you will. Depends on the validation, structure, etc.
It should
Hmm?
It should be.
So what you're saying here is instead of doing it like this, you would in the titles set method, you call validate title method instead and do the testing method instead.
Yeah, so your question is if I would, instead of writing the title here, I would call a validate title method. Yes,
Yeah.
I would call a validate title method, and I would have different tests for it. Like validate title that's empty should actually return false. Validate title bigger than X characters should return false, etc. I would have one or two true cases, and most of the time I'm looking for a lot of false cases in validation. Okay? Other questions?
I'm still amused about latitude 90.
Oh, latitude. Okay.
It's way beyond the North Pole.
We're pretty close to the North Pole right now, aren't we? Feels like it.
We're about 60, latitude of 60.
Okay.
And the North Pole is latitude of 90.
Yeah.
So,
So just 30.
2/3.
It's just 30.
Just 2/3 to the North
2/3, that's very close to me.
Pole.
Okay, so this is the same example as the piece of logic that we assert against. What about this? This is an example of multiple asserts. Okay, can you tell? So I didn't even have room to put all at the beginning of the test. But this is one test method. And what it does is that it creates an array. Let me show you. Sorry. So there's an array of stuff here. And each item in the array is an anonymous object that has two properties. One is a property named parameter. Notice how they all have the same name. And one is an action, which is really a lambda or a delegate that invokes a specific overload of HTML route link. So this is a call to a different HTML route link, etc., etc. And the difference so in the array we have multiple delegates, each one of them calling a different version, a different overload of HTML helper.route link. And then here at the bottom we have a loop that goes through each one of them and uses exception helper.expect argument exception null or empty. Okay? Now what this means, what is exception helper? This is using MS Test. MS Test doesn't have assert.throws like NUnit, although it takes about 5 lines of code to create it. So this team who wrote this created an exception helper that does exactly what assert throws does. So this is why it uses that. So it goes through each one of the items in the array and then asserts that it throws an error, or in terms of readability, I'm not sure. It might assert that it's not throwing an error. So I'm not sure if it means you expect an argument exception that is null or empty, or you expect an exception of an argument null or empty. Okay? So it's kind of a problem in terms of readability. I'm not sure. And this is exactly the opposites. I'm not sure if you expect an exception or expect no exception here. That's a problem. But usually, when people would use exception helpers, is that they expect throws. So I'm assuming that they're expecting exceptions here. So what's the problem with this? Is this a good test?
Isn't it basically lots of tests in the same test?
Yes, it's multiple tests in the same test method. So what's the problem?
If it fails, do you really know which of the tests that failed?
If it fails, you don't know which one of them failed. Yes, what else? Even worse, if it fails in the middle, everything after the middle will never get executed. The loop is going to break. Right? Because there is no try-catch inside the loop here. So if the exception helper throws an exception because it fails, the test fails. And so maybe the bottom 3 overloads never get executed. And this is an example of a case where you do care about each one of them separately, because each one of them is a separate overload. It's a separate method, actually. Okay? So yes, you do need a separate test for each one of them, or at the very least, you have to fix the loop so that it doesn't break at the test, and then you have to log everything that failed when the test finally does fail. So you have to build some infrastructure in this loop. And loop, by definition, are a piece of logic. They can actually have a bug, etc., etc. So the simpler case would just be a separate test case for each one of them. Yes?
One question. So hopefully I will never create lots of frameworks with multiple overloads, because it creates this problem. So I have a lot of different overloads that I have to check. But also when I go back to, if I understand correctly, I would check the individual values. So all the different versions have to be checked. So I get lots and lots of tests for that. Is that correct? Would you do this?
Well, in this case, I says it really depends on the domain, what's important and what's not. Let's assume that these are the important tests. So whatever they test is what I would test. It's separate tests. Okay? Maybe for this domain, it would make sense to also add a couple of more tests. Maybe not. It really does depend on the domain. Okay? So whether I would have multiple tests with different inputs to different parameters for each overload or not, really I don't know. If I knew the domain, I would know. Here's an example of something that this is an example of over-specification. Now, there are multiple things wrong in this test. Let's start with trying to understand what's going on here. So let's look at the name of the test. Does anyone care to read the name? Okay, I'll read it. Invoke action throws if begin invoke action method throws thread abort exception. Now you should say that 5 times fast. This is where the underscores start to make sense. Where does something start and something end? It's really hard to read that. So invoke action throws. Now it throws when begin invoke action throws something else. So we're expecting at the end to expect an exception. And there is this one here. So this is, the name tells us this is the important part. But then if I look at the end of the method, there's something interesting going on here. Mock helper.verify. What is mock helper? All these things. Okay, so all these things are a usage of mock, and expect is the previous version of setup method if you've seen it before, and basically it looks at everything that's verifiable, and if I said verifiable, when I call verify at the end, then verify will go through all the verifiables and make sure that they're called. Okay, so really I have 1, 2, 3, 4, 5, probably 6 asserts in this single verify. And the funny thing is that I shouldn't even care, because this is what I care about. This is the expected end result, is that I get back an exception. So the big question is, why do I have both an expected exception and the verify in this method? What's the basic idea? Well, there is no good reason. The only good reason that used to be is that people would, including me, would verify all the interactions just because they could. That used to be the norm. So I remember writing tests where at the teardown method, at the end of each test, I would also verify all the interactions, just to make sure. There was something about that, you felt like you had power to do that. But the problem is that you're really cementing all the internal implementation that you have over here. This is all internal implementation. This is all really stubs that return specific results so that I can test whatever it is that I'm testing. And this is kind of like me sending my kid out to get pizza and telling him, look, when you get back, I need a pizza that looks like this. And then when the kid comes back with the pizza, not only do I verify the pizza, I also pick up the phone and I call the guy at the pizza store and ask, hey, did a kid come by? Did he pay you exactly this amount of money? Did he say exactly these specific words? Did he arrive? Did he put the right foot first when he got in through the door, or the left foot? Because it would have been the right foot. And if the guy said, look, he was the left foot, I would throw the pizza out to the garbage, because that wasn't what I said would be. And that's exactly what's happening here. If tomorrow the internal implementation of the method would change, as long as I still got the expected exception at the end, what do I care, right? The method, the application still works. I shouldn't care about this. But in fact, this test is the strictest test I could ever see, because it says that every method has to be called. And you know what happens if if a method gets called twice instead? The test will break. He's going to say, you said it's going to be called once. So this is an example of what's called over-specification, where you have tests that verify internal implementation instead of just the expected end result. Okay? There are two problems here. One is that I shouldn't have a mock object anyway, like just stubs. And while I have the mock object, I shouldn't be verifying multiple things on it. Questions? Okay, here's another example of a test. This is a different test, although it's hard to see. Execute core with a synchronous invoker and action completes successfully. What does complete successfully mean? Complete successfully. What does that mean? What do you think it means?
Didn't fail.
It didn't fail. No exception. Okay, so it's not expecting any exception. Why do I have two mock objects right here? What the hell is going on here? Well, it's the same as before. We verify just because we can, but there's a different problem here. Here we have two mock objects in the single test. And a test should have no more than a single mock object, because every mock object is testing a specific thing. So at the very least, one of them is either unnecessary or has to be used in a separate test. Because if the first one it fails, we'll never know if the second one fails in this test. But do we even need both of them? Based on the name of the test, we don't. Based on the name of the test, we just are expecting no exception. Okay? Now, even from the name of the mock objects, I can see, and I can see that one is called mock temp data provider. What is provider? Provider means that the direction of the information is internal, is into the application. It's not external. It's something that provides information into the application. When I see the word provider, I'm thinking stub, because I'm going to use it to create fake data so I can test my application. This is probably not supposed to be a mock object, but people verify it because they can, because that used to be the norm. What about the second one, mock invoker? Where does this get used? So we have expect here, begin invoke action, and then it returns something. Then end invoke action, it returns true. So this is again a stub. It returns something into the application. But we don't need to verify that it was called. We just need to say, if this returns true, and it returns whatever we need, then do we get back no exception? Execute with the synchronous and action complete successfully. Now, the problem is that we're verifying that it got called. A better way to check that it actually got called, or that it actually works, is that the asynchronous action actually does something. It would be a much better way to get a real value that went through the system as it worked. Okay? But this is an example where people didn't know what to test for, so they used a mock object. But again, you're verifying that begin invoke and end invoke action got called, when in fact you shouldn't be doing that. You should just assume that whatever is execute core, where is execute core? Execute core is this. You should assume that begin execute core does whatever it needs, and if it does the work, then you should get back some kind of value from it. That would be a better way, a state-based test, that you get back a return value or that something in the system changes. I wouldn't use a mock object here, but just stubs and then check a value that I can do something in the synchronous action, like set a variable locally and then see that it actually got set. Okay? Right now, all it proves is that it calls the begin stuff and end stuff, but it doesn't prove that it does anything. And I want to prove that it did anything. If my kid came back with a pizza, I wouldn't even look at the pizza. I would just call the delivery guy or the pizza guy, and that's how I would become less hungry. If he told me that my kid bought the pizza, that doesn't make sense. I need to eat the pizza. Okay, I'm not just saying that because we're just before lunch and I'm hungry. Okay, but this is an example of a test that says what's really important to me is that you called this. I don't care if it actually got something back or that you did anything. I just care that you called someone. And I've seen a lot of tests like this where people verify that some virtual method got called or verify that some base class method got called instead of verifying the actual action. And when you can verify an actual action, it's much better than verifying an interaction. So I would go so far as saying that mock objects or interaction tests should be no more than maybe 5% of your projects, of your code. They should be not the norm, they should be the exception of having mock objects in your tests. Because they're harder to read, and they don't tell you what really happened, they just tell you that something got called. Sometimes that's the only thing you can do, but sometimes not. And whenever you can do something different, you should do that. Okay? This is an example of another anti-pattern that I can see in a lot of tests in terms of readability and maintainability, where people will create, at the top you can see how people will create a chain of objects. So you have a mock principal, which is really a fake principal, that returns a fake identity. It returns a fake identity here. So that's how people might return a chain of fake objects. But all the latest frameworks, including mock, Rhino, and Isolator, have introduced the idea of recursive fakes, where you can create an instance of iPrincipal, and principal.identity will already be fake in the single line of code. So every property that is an object of a fake object will be a fake object. And every property that is a value object will have a default value. So we shouldn't do hard-coded chains in code anymore. We can just use the frameworks to give us that extra edge in terms of readability and maintainability of the tests. Because what happens if someone now uses the identity dot something in our test? Now we have to go and add another line of code if we were doing it the way we did the upper way. To all the tests that use this. That's a problem. So we talked about structure. We talked about method naming, but let's just make sure this is an example of a really bad name. Register get. There is no expected behavior. Just look at the assert here. Assert are equals 6. Result view data password length. What does that even mean? What's the assert? What are we trying to prove here? Where did 6 come from? Well, the name of the test doesn't really say anything, so we have to assume that the person who wrote this has no idea. Had no idea why, what to assert here, so they just asserted something on the result. But 6 is also a magic number. And again, where do magic numbers come from? Well, in this case, this magic number came from here. Can you see the 6? So we have, somewhere in our test, we have a mock or a fake membership provider that has a hard-coded minimum required password length of 6. And that's an example why our test should be setting these values in the first place, so that we don't have to do this kind of stuff. Here's another example of magic values and behavior. This is an override of creating a user in the system, in the fake system. Now, here's the important thing. There is a lot of logic here. So if I have a username, and the username equals some user, and password equals good pass, and the email equals an email, then the status of creating a membership is success. So every user in every test to create a good user has to provide these values. and somehow they magically are supposed to know that these are supposed to be the good values. What if I wanted to return a non-successful one? Oh, that's very simple. So in the email, I would send in a string with the name, of the enum for which I want the status to be. Okay? So the email, instead of email, should contain the name of an enum value from membership create status. So it should be membership create status dot something as a string in the email. It's like a really powerful magical incantation that you have to really know. It's like a magic password that says, shh, I want you to create a non-working status. Just look in the email. No one will find this out. Okay, there's no way for people to find this out. It's not explicit. It should be explicit. Either by creating a public static property or some settings somewhere that the test would set, and this would use these settings. That's how it should be. It shouldn't be hidden from the tests. It should be explicit in the test what's going to happen.
Which is a good idea for the interface that you are testing, that it should include these types of enumerations for texts and so.
Well,
so
this
that
is
you
not
can
the
use them
interface.
before.
Yeah. Is it a good idea for the interface I'm testing to have these enumerations? Well, this is not the interface I'm testing.
No,
This
but
is the stub that I'm using to test
But then
something
the
else.
test of this class, you have a class you will test. So the class or in conjunction with the class, you also have these texts that you will use in the implementation of your class or your library. And then you will use the same enumerations in the test for setup and for checksum.
Yeah, so I would have some maybe shared consts or enumerations that are visible in my tests through some class. And then I would say that my test will create something and use that const to create it. And then here I would use the same const in this code.
Yeah.
And so that I would have a shared knowledge of what's supposed to happen. Yeah.
And then you can have all the arrow texts could be defined in the class, or maybe if you are checking against the arrow texts or contains this.
If I'm looking for a specific error that's hard-coded into a stub in the system, then the stub would use a const, and I would assert using that const as well, so that I know where it's coming from.
Yeah.
Yeah.
And also maybe the class you're testing, if that class has defined these texts, like that you can use them, both setting them in the stub and in the...
Yes, if the class contains these texts, then I can go directly and say, I'm expecting the error to be the class dot some expected error, or some error default value.
Because that type of information is a part of the API that you are testing.
If it's a part of the API I'm testing, then I can use the const in that API to expect something. But the important thing is that even before that, I need the reader of the test to understand why should he get that error in the first place. So there should be a stub somewhere that sets a false result. I need to see the test telling that stub to return a false result.
So you have it both in the definition of the test and in the verification, or...
Yes, I would have it in the arrange part. I would see what's going to happen, and then in the assert I will see what should have happened. Yeah. Here's an example of a magic number. Inject me and 15. Not sure what 15 is. Could be a million different things. The number of methods in somewhere, number of files, etc. We're talking about naming. Okay, so what we're going to do now is we're going to head off to lunch, and when we come back, we're going to do some test review exercises. Okay?
if you have this test driven, to buy